All right, so let's do the question 10 from the poll as our first practice problem here. So question 10, let me just write it out here for you guys on the whiteboard. This is a Hardy-Weinberg practice problem. In a population of 100 humans, 16 display the homozygous recessive condition of albinism. Use the Hardy-Weinberg equation to calculate values for the following genotypes. Homozygous dominant, heterozygous, and homozygous recessive. Okay, so essentially what I recommend that you do is you kind of make yourself a little bit of a summary. So based upon that word problem, the information that we have, total population size is 100 humans. And we know that homozygous recessive, which is the Q squared portion, is going to be 16 out of 100. Okay, so then if we know that 16 are homozygous recessive, then we know that the remaining humans, the 84, have to be either homozygous dominant or heterozygous. Okay, so 100 minus 16. I'll show you on the calculator here. Okay. If you don't already, just make sure you've got out a basic calculator and some scratch paper. So if we know there's 100 total in the population and we know that 16 are homozygous recessive, then that means that the other 84 have to be either homozygous dominant or heterozygous. Okay, so that's kind of our summary. So I recommend you always make yourself a summary. The first thing you do when you're reading these practice problems, make yourself a summary. And then the next thing you're going to do is start with the value of the homozygous recessive. So that's represented by Q squared. So Q squared is going to equal the number of homozygous recessive individuals. So 16 divided by the total number in the population. So 16 divided by 100. I already put that in your calculator. 16 divided by 100 is what? You can either say it verbally or put it in the chat box. 16 divided by 100, rounded 2 decimal places. All we're doing is putting 16, dividing it by 100, and then you're giving me the answer rounded to 2 decimal places. Ooh, okay, 0.16 is correct. Carla, I think you were just skipping ahead one spot because Q squared is 16 divided by 100, which is 0.16. But to isolate just the value of Q, which is the next step, so we're going to do the square root. That's okay. That's why we practice like this. We do the square root, and then that's going to give us the value of just Q. Okay, so Q, the singular Q, is going to be 0.40. Okay, because if we take the square root of 0.16, we get 0.40. Okay, so now we know that Q equals 0.40. And we know, based on the elements of the equation, that P plus Q has to equal 1. So then all we have to do is invert it. If we want to find the value of P, all we have to do is take 1 minus the value of Q, which is 0.40, gives us 0.60, like that. Okay, so now we have our value of P and we have our value of Q. We know that Q has to equal 0.40, and we know that P has to equal 0.60. All right, is everyone with me thus far? Awesome. Okay, so that's essentially the conclusion of step 1. So once you've done that, the rest of it's a kind of a piece of cake. All you have to do is memorize the equation and what each portion represents. So the equation itself, P squared plus 2PQ plus Q squared is going to bring us back to 1 or 100% of our breeding population. Okay. All right, and my advice is always, always, always set it up exactly like this so it's easy not to get confused. Okay, so P squared just means the value of P multiplied by the value of P. Okay, so it's 0.60 multiplied by 0.60. Okay, so when I say plug it in, I just mean we're plugging in the values of P and Q wherever we see those variables. Okay, so P squared is the equivalent of 0.60 multiplied by 0.60. All right, the middle part is 2 multiplied by the value of P, which is 0.60, and then multiplied by the value of Q, which is 0.40. Okay, so we've got our P squared, we've got our 2PQ, and then the last part of our equation is Q squared. So Q squared is the value of Q multiplied by the value of Q. It's hopefully going to bring us all the way back to 1. Okay. All right, so now we've got it all set up. All we have to do is plug in those numbers into our calculator. So everybody plug into your calculator 0.60, and then you can either hit the square button or just do 0.60 multiplied by 0.60. And give me your answer rounded to 2 decimal places. Beautiful, Joseph. 0.36. And that's representing the homozygous dominant genotype. So if we wanted to turn that into a percentage piece of cake, all you have to do is move that decimal 2 places to the right. That becomes 36%. Okay, and then the middle part of the equation. So we're just punching numbers in our calculator now. Now that we've got it all nicely, beautifully set up. So we're taking 2 multiplied by 0.60 multiplied by 0.40. And then give me your answer rounded to 2 decimal places. Just somebody other than Joseph. Can you give me 2 in your calculator? 2 multiplied by 0.60 multiplied by 0.40. And then just giving me your answer rounded to 2 decimal places. Excellent, Carla. 0.48. And that's representing the heterozygous genotype. So the big A, little a portion. And if we want to turn that into a percentage piece of cake, all we need to do is move that decimal 2 places to the right. So 0.48 becomes 48%. So we now know that 48% of our population is heterozygous for skin pigmentation. Okay. All right, and then the very last part of our equation, we're taking the value of Q squared. So we're simply putting in our calculator 0.40 multiplied by 0.40. And then go ahead and give me your answer rounded to 2 decimal places. So somebody other than Joseph or Carla, in your calculators, what's 0.40 multiplied by 0.40 and then round to 2 decimal places. Excellent, Janelle. 0.16, and that's representing the homozygous recessive portion of the population. If we want to turn that into a percentage, piece of cake, all we do is move our decimal 2 places, and that becomes 16%. So that's kind of back to the beginning of our equation. We know that 16% of our population is homozygous recessive for albinism. Okay, and then just to check your answers, do 0.36 plus 0.48 plus 0.16, and then do 36% plus 48% plus 16%. Do you get back to 1 and 100%? Give me a thumbs up if you got back to 1 or 100%. Excellent. Nice work, everyone. Okay, so your answer to that last poll question, number 10, the value for heterozygous should have been 48%. Okay, 48%. All right, so let's go ahead and do the practice problems and check in assignment number 2. So my goal for you guys today, as long as you're here, as long as you're paying attention, as long as you're taking notes, your homework will be done by the time we leave here today, as long as you've read your chapter. Your homework will be done for today. All right, so we're going to do practice problem number 1 from check-in assignment number 2. All right, so this one is looking at dimples in humans. So for humans, the condition of dimples is dominant over non-dimples. Okay, let me just go ahead and erase the board here so that we can do a new problem. All right, so this is practice problem number 1 from check-in assignment number 2. Okay, so I just copied and pasted it. Move it over a little bit. Okay, so practice problem number 1, the alleles for dimples is dominant. In a population of 1,000 individuals, 200 individuals have no dimples. So in order to have no dimples, they have to be homozygous recessive. So we're going to use our Hardy-Weinberg equation to determine the frequency of the dominant and recessive alleles. And then we will determine how many individuals we would expect to be homozygous dominant, heterozygous, and homozygous recessive within our population. Okay, so we want to start out by doing a little summary. So we've got total population of 1,000. It's 1,000 humans. And then homozygous recessive, so little d, is going to be 200 out of 1,000 humans. And that means that the other 800 have to be either homozygous dominant or heterozygous. Okay, so 800 out of the 1,000 humans have to be either homozygous dominant or heterozygous. Okay, so it's just a little summary of the information that's already in your board problem there. Okay, so that's just a little strategy I like to use to make the word problems easier to understand. At least it helps me. All right, so now with the Hardy-Weinberg equation, remember we always want to start with the known quantity, which in this case is the homozygous recessive condition. So that's Q squared. So to determine the value of Q squared, we need the number of homozygous recessive individuals, which in this case is 200. And then we're going to divide it by the total in the population. So you guys tell me in your calculators, what's 200 divided by 1,000, and then round it to 2 decimal places. And then you can either say it verbally or you can write it in the chat. Excellent, Janelle, 0.20. So that's our value of Q squared. So remember, we want to isolate the value of just Q. So what do I need to do to that number to find the value of just Q? I need to take the square root. So in your calculator, it's the check sign with the line above it. All right, so you guys tell me in your calculator, what's the square root of 0.20 rounded to 2 decimal places? Excellent, Janelle, 0.45. So that's our value of Q. And we know that P plus Q is going to have to get us back to 1. So if we know that, and we know the value of Q, all we need to do next is take and 1 minus the value of Q. We take 1 minus 0.45. So we're just inverting it here, and that's going to give us 0.55. All right, so now we know both. We know our value of Q is 0.45, and we know our value of P equals 0.55. Okay, so in my opinion, as long as you remember that part, the rest of it's a piece of cake. Okay, all you have to do is remember that part, how to find the value of P and Q. And then you also definitely need to memorize the Hardy-Weinberg equation and what each element of it represents. So step 2 over here, we're going to write out the Hardy-Weinberg equation. So we're going to write P squared plus 2PQ plus Q squared is hopefully going to get us back to 1. Okay, so now all we have to do is plug it in. So when I say the words plug it in, I mean we're plugging in the values of P and plugging in the values of Q. So wherever I see a P, I'm plugging in 0.55 because that's our value for P in this equation, or in this circumstance, I should say. And then wherever I see a Q, I'm going to plug in 0.45. And my advice is always, always, always set it up this way. I know it may seem slightly repetitive, but I promise if you set it up this way, you're going to guarantee that you get the right answer each time. All right, Q squared, so we're just taking our value of Q, which is 0.45, multiplying it by the value of Q, which is 0.45. And hopefully that's going to get us all the way back to 1. All right, so now that we have it all set up, the next step is just plugging it into the calculator. All right, so you guys tell me in your calculators, what is the value? 0.55 multiplied by 0.55, and then rounding to 2 decimal places. Excellent, Carla. 0.30 is going to be our value for homozygous dominant. If we want it as a percentage, piece of cake, we just move our decimal 2 places, and that gives us 30%. Okay, so we know that 0.30 is the frequency, and 30% is the percentage. Okay, and I'll tell you how to do individuals here in a second. Okay, but middle part of the equation, so punch in your calculator, 2 multiplied by 0.55 multiplied by 0.45, and give me your answer rounded to 2 decimal places. Okay, almost, Joseph, but look at that third number. So when we're rounding, when we look at that third number, if it's 5 or above, we do what? We got to round up. If it's 4 or below, we're going to keep it the same, right? So it's 0.50. Beautiful. So that's our value for heterozygotes. We want to turn that into a percentage, piece of cake, 50%. Okay, so now we know that 50% of our breeding population is heterozygous for dimples. All right, last part of the equation are homozygous recessives. So in your calculator, just punch in 0.45 multiplied by 0.45, and then give me your answer rounded to 2 decimal places. Excellent, Carla. 0.20. Excellent, Francisco. So we know that 0.20, that's the frequency, or 20% of our population is homozygous recessive for dimples. Okay, now 30% plus 50% plus 20% gets us back to 100. So we know we did it correctly. Now, if the problem is asking about number of individuals, you simply take the frequency and then multiply it by the total humans in the population, or total individuals, whether it's humans or zebras or rock pocket mice or fruit flies, whatever it is. So you're taking the frequency and you're multiplying it by the total number of individuals in the population. So everyone in your calculator, what is 0.30 multiplied by 1,000? 300. Beautiful. So 300 humans in this case are going to be homozygous dominant for dimples. All right, in your calculators, what's 0.50 multiplied by 1,000? 500 humans. So we know that 500 humans in this population are heterozygous for dimples. All right, and then the very last part, what's 0.20 multiplied by 1,000? Beautiful, Janelle, 200. So we know that 200 humans are homozygous recessive for dimples. Okay, and when we do 300 plus 500 plus 200, we get back to 1,000, the total number in the population. All right, pretty easy, right? As long as you follow those steps, it's easy peasy. We really, in my experience, students really only get into trouble when they don't follow these steps. So even though it may seem just a little bit repetitive, I really do encourage you to follow these steps regardless. Okay? All right, let's do one more together, and then I'm going to have you guys do some in your breakout rooms together. Okay? Let me go ahead and erase these. And also today, I may be awarding some extra credit points for those of us that are participating in the chat box or verbally, however you want to do it. I may be awarding some extra credit points for those that participate. Okay, so I'm going to go back to my worksheet here and I'm going to pull up practice problem number 2. Okay, so practice problem number 2 is going to be looking at earlobe form. So in humans, there's 2 conditions. There's the attached earlobes and the free hanging. The free hanging earlobes are the dominant condition. Okay, so practice problem number 2, the allele for free hanging earlobes, big E, is dominant over the allele for attached earlobes. In a population of 10,000 individuals, 2,500 have the attached earlobes, the homozygous recessive condition. So we're going to use the Hardy-Weinberg equation to determine the frequency of the dominant and recessive alleles. And then we're going to use those values to determine how many individuals will be homozygous dominant, heterozygous, and homozygous recessive. All right, so we're going to start out with a little summary of our word problem here. So we know that the total population is 10,000 individuals. And we know that homozygous recessive, so little e, has to be 2,500 out of the total 10,000 individuals. And we know that the remaining portion of the population, so if they're not homozygous recessive, they have to be either homozygous dominant or heterozygous. So we just take in our calculators, we simply take 10,000, the total in the pop, and then we subtract 2,500. So we know that 7,500 individuals out of 10,000 have to be either homozygous dominant or heterozygous. Okay, so we've got our little summary of our problem there. And then now we're going to use the Hardy-Weinberg equation. So remember, we're always going to start with homozygous recessives. So Q squared is going to equal the number of homozygous recessives, so 2,500 divided by 10,000. All right, so you guys tell me in your calculators what's 2,500 divided by 10,000? $2,500 divided by 10,000, 0.25. Nice job, Kevin. Nice job, Joseph. 0.25. Okay, now careful. This is the value of Q squared, but we want to isolate the value of just Q. So we need to do what to that number? We need to take the square root. So the check sign with the line above it. All right, so you guys tell me what's the square root of 0.25 rounded to 2 decimal places? .50. Nice job, Carla. Nice job, Janelle. So we know that Q has to equal 0.50. And we know, based on the elements of the equation, we know that P plus Q has to equal 1. And we've already got our value for Q. So essentially all we need to do is invert that equation and we'll find the value for P. So we're just taking 1 minus our value of Q, which is 0.50. And that's going to give us our value of P. So 1 minus 0.50 gives us 0.50. So we now have our value of Q and we have our value of P. So that's the end of step 1. And then step 2 is the easy part, as long as we've memorized our equation. So step 2 just simply involves us plugging in those values of P and Q into our Hardy-Weinberg equation. Okay, so we're going to write out the equation first. P squared plus 2PQ plus Q squared is going to bring us all the way to 1. Okay? So we're just going to plug in our value. So wherever I see a P, I'm going to plug in the value of P. So I see a P, so I'm going to plug in 0.50. So P squared is the equivalent of P multiplied by P. So it's 0.50 multiplied by 0.50. And then the middle part, 2PQ. So 2 multiplied by the value of P multiplied by the value of Q. Okay, and then the very last part of our equation, the Q squared. So we're simply taking the value of Q and we're multiplying it by the value of Q. So 0.50 multiplied by 0.50. All right, so you guys tell me in your calculators, what's 0.50 multiplied by 0.50? Excellent, Kevin. Excellent, Joseph. 0.25. So we know that 0.25 is our value for homozygous dominant. Simply because we know P squared, so this is just memorization. So what we learned on Monday, we learned what each part of the equation represents. So we know that the P squared portion represents the homozygous dominant individuals. So we know that 0.25 or 25% of our population has to be homozygous dominant for earlobes. Okay, middle part of the equation, what's 2 multiplied by 0.50 multiplied by 0.50, rounded to 2 decimal places? Excellent, Joseph. 0.50. And that's the value for the heterozygotes, or if we want to change that into a percentage, piece of cake. We just move our decimal 2 places, that becomes 50%. Okay, and then the last part of our equation, the Q squared. So we're taking 0.50 multiplied by 0.50 and give me your answer rounded to 2 decimal places. Excellent, Carla. 0.25. And that's our value for the homozygous recessives. We just move our decimal 2 places to get percentages. Okay, and then if we want to know number of individuals, remember we take the frequency and then we multiply it by the total number in the population. So you guys tell me what's 0.25 multiplied by 1,000? Oh, almost, Kevin. In your calculator, 0.25 multiplied by 10,000. Excellent, 2,500. So 2,500 humans, in this case, have to be homozygous dominant for earlobes. All right, now in your calculator, so we're going to take the frequency that goes along with the heterozygotes. So 2PQ represents the heterozygous. So we're simply following it down. We're taking the frequency associated with the heterozygotes, 0.50, and we're multiplying it by the total in the population, which in this case is 10,000. So 0.50 multiplied by 10,000. Excellent, Kevin. Nice work. 5,000. So we know that 5,000 humans must be heterozygous for earlobes in this case. All right, and then the very last part, so back to 25% again. So 0.25 multiplied by 10,000 gives us what number? 2,500. Excellent, Kevin. So 2,500 humans must be homozygous recessive or have attached earlobes. Okay, so we have it all lined up like this. We've got the homozygous dominants lined up here. We've got the heterozygotes lined up here. And then we've got the homozygous recessives lined up here. All right, so when we do 0.25 plus 0.50 plus 0.25, we get back to 1. When we do 25% plus 50% plus 25%, we get back to 100% of the population. And then finally, when we do 2,500 humans plus 5,000 humans plus 2,500 humans, we get back to 10,000 humans. So we know we did it correctly. All right, let's actually do one more together. Let's do one more together, and I'm going to have you guys do 2 in your breakout rooms. But I would love to see everyone participating because this is some easy extra credit points. And also, this is good practice for your test. Your first exam is going to be next week. So next week, we have class on Monday. We're going to play some Jeopardy or Kahoot. And then we've got class on Wednesday. And then we'll have our exam due by the end of next week. Okay, so my advice is take advantage of this time and make sure you really understand how to do these problems. Okay, all right, so we're gonna do one more together. I would love to see everyone participating. And then we'll do a couple in our breakout rooms together. Okay, let me just find the right document. Okay, so this is practice problem number 3 from your check-in assignment number 2. So we're getting our homework done as well. All right. Let me paste it in here. All right, practice problem number 3. The ability to taste the chemical PTC is controlled by a dominant allele, an uppercase T. In a population of 5,000 individuals, it was determined that 750 of the individuals were unable to taste PTC. So 750 out of the 5,000 are homozygous recessive. Determine the frequency of the dominant and recessive alleles. And then using the values of P and Q, we're going to determine how many individuals we would expect to be homozygous dominant, heterozygous, and homozygous recessive. So let's make our little summary. So our total population, and we're talking humans again. So our total population is 5,000 humans. Out of those 5,000, 750 out of the 5,000 are unable to taste PTC. So they have to be little t, little t. And then the remainder of the population, so if they're not little t, they have to be either big T, or big T, little t. So we just take 5,000 and we subtract 750. So we know that 4,250 have to be either homozygous dominant or heterozygous. Okay, so that's our little summary just based on the information that's already there in our word problem. So with the Hardy-Weinberg equation, we always start with a known quantity, which is the homozygous recessives. So Q squared is going to be the number of homozygous recessives, so 750 in this case, divided by the total in the population, which is 5,000. All right, so you guys tell me in your calculators what 750 divided by 5,000 rounded to 2 decimal places. Okay, careful, Kate. So it's 750. There we go, 0.15, because it's going to give you a totally different number if you don't get that decimal place in there. Okay, so Q squared is 750 divided by 5,000 is going to give us 0.15. So just be careful if you move decimal places around or forget them, it's going to mess up your answer. So just be specific. So that's our value of Q squared. So if we want the value of just Q, if we're going to isolate just Q, we need to take the square root. So that's the button in your calculator that looks like a check sign like this, the line above it. All right, so you guys tell me what's the square root of 0.15 rounded to 2 decimal places. Beautiful, 0.39. Nice work, Carla. Nice work, Francisco. Okay, so that's our value of Q. Okay, and we know based upon the elements of the equation And it's just memorization here, guys. We know that P plus Q has to equal 1. Okay, so then all we have to do is invert the equation because we already had the value of Q. So we just invert the equation. So we take 1 minus our value of Q, 0.39, and that's going to give us 0.61, right? So there's our value of P. So we know that Q has to equal 0.39, and we know that P has to equal 0.61. All right, so that right there, that's essentially the conclusion of part 1 of the Hardy-Weinberg equation. So once you've done that, once you understand that, all you have to do is plug in your known values of P and Q into the Hardy-Weinberg equation itself. So P squared plus 2PQ plus Q squared, hopefully it's going to get us all the way back to 1, or 100% of the population, however you want to think about it. Okay? So my advice is always, always, always set it up this way to avoid confusion. All right, so P squared just simply means the value of P multiplied by the value of P. So 0.61 multiplied by 0.61. All right, middle part of our equation. So we're carrying down the 2, and we're multiplying it by the value of P, which is 0.61. And then we're multiplying by the value of Q, which is 0.39. So that's our middle part of the equation there. And then our last part of the equation, the Q squared. So we're taking the value of Q, and we're multiplying by the value of Q. So 0.39. And then we're multiplying by 0.39. Okay, and then hopefully that's going to get us all the way back to 1. All right, and my advice is always line up your equation just like this. That way you won't get confused accidentally. All right, so now next thing we have to do, just punch it into our calculator. So we're doing P squared first, so 0.61 multiplied by 0.61, and then give me your answer rounded to 2 decimal places.
0.39?
Not 0.39, so we're doing 0.61 multiplied by 0.61,
Pardon me.
and then we're going to round our answer to 2 decimal places. So a basic calculator, so I'm just using the one on my cell phone. A basic calculator will be fine. So you're just taking in your calculator on your cell phone, 0.61 multiplied by 0.61. And the number I'm getting is 0.3721. Okay, so then to round it to 2 decimal places, we want to look at that third number past the decimal place. And since that number is below 4, we're going to leave it as 0.37. Okay, is that what you guys are getting? Beautiful. Nice job, Francisco. Okay, so 0.37, that's our frequency for homozygous dominant. If we want to turn that into a percentage, piece of cake, 0.37, we just move our decimal 2 places to the right, and that becomes 37%. Okay, so we know that 37% of this population must be homozygous dominant for the ability to taste PTC. So they are, in fact, those 37% of people, they are, in fact, able to taste PTC. All right, middle part. So we're pulling up our phone calculators again. 2 multiplied by 0.61 multiplied by 0.39. And then give me your answer rounded to 2 decimal places. Ooh, almost, Joseph. So remember, when we're rounding to 2 decimal places, we have to look at that third number. Since it's 5, then we have to round up. Excellent. Nice job, Francisco. Nice job, Carla. Nice job, Joseph.
I got
it has to be 0.48.
Cool.
So 0.48 is going to be our value for the heterozygotes. If we want that as a percentage, we just move our decimal 2 places, and that becomes 48%. Okay, so we know that 48% of our breeding population is heterozygous for the ability to taste PTC. All right, then last part of the equation. So in your calculators, pulling up your cell phone calculators again, or whatever calculator you're using, 0.39 multiplied by 0.39. And then we're going to round that to 2 decimals. Excellent, Joseph. Excellent, Francisco. Okay, so 0.15, that's the frequency for homozygous recessive, or 15%. Okay, now if we want to know number of individuals, all we need to do is take the frequency and multiply it by the total number of individuals in that breeding population. So if we want to know how many individuals are homozygous dominant, how many humans, we simply take 0.37, and then we're going to multiply it by the total in the population, which is 5,000. So you guys tell me, nice work. Excellent, Joseph. So 1850, 1,850. That's the number of humans that are homozygous dominant for the ability to taste PTC. All right, now in your calculators, what's 0.48 multiplied by the total in the population, which is 5,000?
2,400.
2,400. Beautiful. Nice work, guys. So 2,400 humans have to be heterozygous for the ability to taste PTC. Nice work, Francisco. And Julian, who verbally answered, I believe. All right, then the last part of the equation is the Q squared. So in your calculators, we're just taking the frequency, 0.15, multiplying it by 5,000, and gives us 750. Nice work, Francisco. So that's kind of back to the beginning of our equation. So 750 humans have to be homozygous recessive. Okay, so just double check to make sure we're correct in your calculators. So we're going to just punch in the numbers to make sure we're correct. So 0.37 plus 0.48 plus 0.15 gets us back to 1. So your frequencies will always equal 1. Your percentages will always equal 100. So 37% plus 48% plus 15% gets us back to 100. We're good there. And then your number of individuals for each genotype will always get you back to the total in the population. So 1850 plus 2,400 plus 750 gets us back to 5,000. So we know we've done it correctly. Okay, so next thing we're going to do, so I'm going to give you 2 practice problems. I'm just going to give you one first, and then I'll give you a second one in about 10 minutes. But I want you to make sure that you guys are able to do this because, I mean, obviously it's important for your homework assignment this week. But additionally, it's important because there's going to be about 5 of these questions on your next test. Okay, so it's important for multiple reasons. So I'm going to put you guys into breakout rooms. And this first one, I want you guys to try together. So I believe when you're in the breakout rooms, I believe you can pull up. So I'm going to pause the recording right now. Okay, so practice problem number 5. In a population of 100 zebras, 36 display the homozygous recessive condition of spots. So we're going to use the Hardy-Weinberg equation to determine the value of P and the value of Q. And then we're going to use the values of P and Q to determine the percentages of each genotype. So just like we normally do, we're going to determine the percentages of homozygous dominant, heterozygous, and homozygous recessive. So the way I recommend doing it, just give yourself a little summary. So total in the population is just 100 zebras. 100 zebras. Okay, and then we have homozygous recessives are going to be 36 out of 100 zebras. And then those that aren't homozygous recessive have to be either homozygous dominant or heterozygous. So we know that, so 100 minus 36. So in our little handy dandy calculators, so we're going to do 100 minus 36, and that gives us 64. So we know that 64 zebras have to be either homozygous dominant or heterozygous. Okay, so we've got a little summary there. Then we always start with the number of homozygous recessives divided by the total in the population, which is going to give us Q squared. So Q squared equals 36 divided by 100. So you guys tell me, type it in the chat box for me. 36 divided by 100 rounded to 2 decimal places is what number? Excellent, Joseph. Nice, Francisco. 0.36. So that's our value of Q squared. Okay, so what do I need to do next? I need to isolate the value of just Q. So remember that means I need to take the square root. So I want to hit the button that looks like a check sign with a line above it. So you guys tell me, what's your value of 0.36 square rooted, rounded to 2 decimal places? So 0.36, excellent, Joseph. Nice work, 0.60. So that's our value of Q. Okay. All right, now based upon the components of the equation, we know that's just memorization here. We know that P plus Q has to equal 1. So if we know that and we have the value of Q, all we need to do next is invert it. So we simply take 1 minus the value of Q, which in this case is 0.60, which will then get us back to 0.40. Okay, so now we know that Q has to equal 0.60, and we know that P has to equal 0.40. Okay, so you want to be really careful because this is very similar to another question that we did. But the other question we did, it was the reverse. The other question that we did, I believe, was practice problem number 2 or number 3. That one was inverted. So that one had the value of P being 0.60 and the value of Q being 0.40. So just be careful. Make sure you make yourself a little summary at the end of step 1. So we know that P equals 0.40 and we know that Q equals 0.60. Okay, so then we just plug in those numbers. So 0.40 is going to be multiplied by 0.40. Okay, so what's the answer there? 0.40 multiplied by 0.40 is what number? 0.16. Beautiful. Nice job, Alexandra. 0.16 or 16% of the zebras must be homozygous dominant. All right, excellent. Now, the middle part of the equation, 2 multiplied by P multiplied by Q. So 2 multiplied by 0.40, sorry, 0.60. Oops, nope, 0.40 is right the first time, multiplied 0.60. All right, you guys tell me, what's 2 multiplied by 0.40 multiplied by 0.60? Excellent, 0.48. Nice work, Joseph. So 0.48 or 48% of the population has to be heterozygous for spots. All right, then the very last part of the equation, the Q squared. So we're simply taking the value of Q, which is 0.60. And then we're going to multiply it by the value of Q, which is 0.60. All right, nice job, Michaela. Nice job, Alexandra. So we know for the Q squared portion, our frequency is 0.36 or 36%. Okay, so we check our work. We know that 0.16 plus 0.48 plus 0.36 has to get us back to 1, and it does. And we know that 16% plus 48% plus 36% has to get us back to 100% of the population, which it does. Okay, so we know we did it correctly. All right, so on the problem, if it's asking you what percentage of the zebras would be homozygous dominant, then you just, you know that P squared represents homozygous dominant, you follow it all the way down, you get 16%. If the problem is asking you what percentage of the zebras are heterozygous, you have to memorize that 2PQ represents the heterozygotes. You follow it down and you answer 48% of the zebras are heterozygous. If the question wanted to know what percentage of the zebras are homozygous recessive, then you just have to memorize that Q squared represents the homozygous recessives. You follow it down and you would answer 36%. All right, guys, I know a lot of repetition today, but that's, in my experience, that's the easiest way to learn Hardy-Weinberg and Punnett squares. It's just lots of repetition, okay? So check in assignment number 2. So you're going to find that those questions are already completed. So all you have to do is go in and you're going to fill in a few definitions, and then you're going to fill in just your answers to these practice problems. So homework is easy for you this week if you were paying attention today and if you've already done your reading. If you haven't done your reading, I do highly, highly recommend that you make sure you've read through chapter 4 and make sure you've made flashcards for all of the bold terms. Because next week is our exam. We've got a Jeopardy game or a Kahoot game on Monday. Wednesday will most likely be an optional study day. So for those of you that feel prepared, you don't need to come to Zoom on Wednesday, but for those of you that do, I will have an additional study day on Wednesday, and then your exam, unit number 1 exam, will be due a week from this Sunday. Okay, I know it's coming up quick, so my advice, if you haven't already, make sure you've read those chapters. All right, guys, I will see you on Monday. Have a wonderful weekend. I do have office hours from 4 to 6 today.
Thank you. Have a good weekend.
You're very welcome. You too, Joseph. Thank you, Michaela.
Thank you.
Thank you, guys. Thank you, Kate. Thank you, Kevin. Thank you, Carla.